In this video, we're going to talk about vectors in the plane. Let's compare these two graphs. The one on the left, this is a point on the x and y axes. And this point is represented by x and y values. The one on the right has an arrow. And this is an example of vector. This is a symbol for a vector. A vector has x and y component, and it has direction and magnitude. Magnitude is the length of a vector. So advantage of a vector over a point is that it has a direction and it has magnitude. And here's a definition of two-dimensional vector. You could read this on your own. And I like to focus the magnitude or absolute value of vector v, which is denoted by this symbol right here. And this is how you find the magnitude of a vector or absolute value of a vector. When you have a vector a comma b, all you got to do is find square root of a squared plus b squared. And it is always a zero or positive real number. So let's say you have a vector v, negative 2, 3. And this is how you would draw the vector v. You start from the origin, you plot negative 2 and 3, and you draw the arrow towards that point. So this is a vector of negative 2 and 3. The x component is negative 2, and the y component is 3. Now, how would you find the magnitude or the absolute value of vector v? That is going to be square root of negative 2 squared plus 3 squared, which is going to be square root of 4 plus 9, which is radical 13. So the length of this vector is going to be radical 13. Now we're going to look at velocity, speed, and acceleration of a vector. We're not going to focus on direction of motion because I don't see that on the AP exam. So when you have a particle that moves along a smooth curve, which is a curve represented by a parametric curve, so that its position at any time t is x of t, y of t, where x and y are differentiable functions of t. So particle's position vector is going to be represented by this. Here's x component and y component in terms of t. And the velocity vector is a derivative of x of t, which is dx over dt, and derivative y of t, which is dy over dt. And the particle speed is the magnitude of vector v, which is a scalar, meaning that it is a real number, not a vector. To find the acceleration vector, all you got to do is take the derivative of dx over dt with respect to t and then dy over dt. So let's take a look at some examples. So it says a particle moves in the plane so that its position at any time t greater than or equal to 0 is given by sine of t, comma, t squared over 2. Part A says find the position vector of the particle at time t. So the position vector is going to be just sine t, comma, t squared over 2 using a vector symbol. What about part B? It says find the velocity vector of the particle at time t. So velocity vector will be just the derivative of the x component, which will be cosine of t, and the derivative of the y component, which is going to be t. Now part C says find the acceleration of the particle at time t. So acceleration will be derivative of cosine of t, which is going to be negative sine of t, and then derivative of t, which is 1. So this will be the acceleration. Now part D says describe the position and motion of the particle at time t equals 6. So based on what we found, at t equals 6, the position of the particle will be a sine of 6 comma 36 over 2, which is 18. Velocity will be cosine of 6, comma 6. And the acceleration will be negative sine of 6 and 1. Now this example said a particle moves in the plane with position vector r of t equals sine of 3t, comma cosine of 5t. They want us to find the velocity and acceleration vectors and determine the path of the particle. So in order to find the velocity vector, let's call it v of t. What you need to do is you need to find the derivative of x component. So this becomes 3 cosine of 3t. Don't forget the chain rule, comma negative 5 sine of 5t. And to find the acceleration vector, you got to find the derivative again, derivative of the velocity. So this will be negative 9 sine of 3t, comma, negative 25 cosine of 5t. So now, how do you determine the path of the particle? All you got to do is use your calculator and graph this part in a parametric mode. So let's go to TI-84 and put these values. And let's try to graph this. So this is not a clear graph. Let's go to zoom fit, which is 0. And okay, let's go to zoom square after that. Zoom square, which is number 5. Now, notice that the graph is not that smooth. So in this case, what you want to do is go to Window and lower your T-step. The lower the T-step, the graph gets smoother. However, it might take longer time. So you need to be careful how you set your T-step. Let's make it 0.01 and see what happens. So you do get a nice smooth curve here. So this is a path of the particle. Now it says that the particle moves in an elliptical path, so that its position at any time t greater than 0 is given by 4 sine t, comma 2 cosine t. Part A says find the velocity and acceleration vectors. So velocity is going to be derivative of 4 sine t, which is 4 cosine t, comma, and then derivative of 2 cosine t, which is negative 2 sine t. What about the acceleration vector? Acceleration vector will be, let's call this a of t, and call that a v of t. v of t equals. So the acceleration vector will be derivative of this, which is going to be negative 4 sine of t, comma, negative 2 cosine of t. So here's a vector, here's a velocity vector and acceleration vector. Now part B says find the velocity, acceleration, and speed at t equals pi over 4. So that means what is the velocity of pi over 4? Well, that's going to be 4 cosine of pi over 4, comma, negative 2 sine of pi over 4. And what is that? Cosine of pi over 4 is radical 2 over 2. So it's going to be 2 radical 2, comma. Sine of pi over 4 is also radical 2 over 2. So it's going to be negative radical 2. What about acceleration at pi over 4? It's going to be negative 4 sine of pi over 4, comma, negative 2 cosine of pi over 4. So you end up getting negative 2 radical 2, comma, negative radical 2. Now, how do you find the speed? Speed is the absolute value of velocity. So it's going to be absolute value of velocity of pi over 4. And the velocity at pi over 4 is 2 radical 2, comma, negative radical 2. And to find the value of that, which is the same thing as the magnitude, it's going to be square root of 2 radical 2 squared plus negative radical 2 squared. And that's going to be 8 plus 2, which is radical 10. Now again, don't worry about finding the direction of motion. We don't need to worry about that. Now part C says sketch the path of the particle. That's pretty easy because we're going to use the graphing calculator. And it says show the velocity vector at the point 4, 0. Now we have the velocity vector over here, but they want us to show the velocity vector at point 4, 0. So how do we know what t is? So let's go back to the position. Position is 4 sine t, comma 2 cosine t. So in order to find the value of t, look at the x component. X component is 4, so what we're going to do is we're going to say 4 sine t equals 4. And 2 cosine t is equal to 0. Now let's solve for t. When is this true? This is true. Let's divide by 4 both sides. So you get sine of t equals 1. And sine of what is 1? Well, that's pi over 2, isn't it? So this implies that t is equal to pi over 2. Now let's double check. What is cosine of pi over 2? Cosine of pi over 2 is 0. 0 times 2 is 0. So we found the value of t. So in order to find the velocity vector at 4, 0, we got to say it's going to be the velocity of when t equals pi over 2, which is going to be, plug in pi over 2 over here. You're going to get cosine of pi over 2 is 0, so you're going to get 0, comma, sine of pi over 2 is 1, so 1 times negative 2 is negative 2. So at 4, 0, the velocity vector will be 0, negative 2. So again, using your graphing calculator, you could graph 4 sine t and 2 cosine t in parametric. And when you graph this, when you go to zoom standard, you might not get this right away. You might have to go to zoom fit and zoom square. And you will notice that the graph was going this way. It makes sense because when t equals 0, it's going to be at 0, 2. And when t is pi over 2, it's going to be at 4, 0. Now our vector at 4, 0 was 0, negative 2. So in order to draw the vector, this is what you need to do. So here's the graph. And at 4, 0, vector is at 0, negative 2. So you need to go draw arrow going this way. 0, negative 2. You're not moving in x direction, but you have to go down negative 2 from 4, 0. And to answer part D, it's moving clockwise around the origin because the particle goes this way.